Alright guys, today we're going to focus on simplifying radical expressions, okay? So you can't just get a decimal answer here. So what you have to do is you have to think about what perfect square can I divide 20 by? Well, I can say it's the square root of 4 times the square root of 5. So this would be 2 square root 5. You can't simplify that anymore. Now here, the square root of the quantity p plus 1 squared, well, that's just p plus 1. So here, try to factor it. Well, guess what? That factors into p plus 1 squared, so it's just p plus 1. Okay? Here you have 3 times the square root of 20. Well, remember that would be 3 times the square root of 4 times the square root of 5, which is 3 times 2 times the square root of 5, so it's 6 square root 5. Now here we have a big number, but see how it ends in 25? Then I would divide it by 25, because I know 25 is a perfect square, and you get square root of 25 times square root of 45. So you have 5 square root of 45, but I know that 45 is divisible by 9, so it's 5 square root 9 square root 5, so this is 15 square root 5. And the reason that is because you have 5 times the square root of 9. Well, what's 5 times 3? 15. Okay? Now the next one here, square root of 225, that's just 15. Now here, we got to factor out the 4. So you do this, and then I can change that to square root of 4 times square root of x plus 5. So that's 2 square root x plus 5. Okay, let's take a look at some more things. Alright, so here's the thing. When you have a fraction like this, what we need to focus on is you can separate it. Square root, and then square root of 36 is 6, square root of 49, 7. Or you can think about it ahead of time. But it's very important to separate. Now, here's the thing. Normally, for this next problem, I would not divide the 36 by 12, but here's the thing. You can't have square roots in the denominator. Is 12 a perfect square? No. So before I do anything, I would do 36 divided by 12. So you get, I'm just trying to simplify. So I would just have this, 3a over b squared. And that would be the square root of 3a over the square root of b squared, which is the square root of 3a over b. Okay? So when you have a non-perfect square in the denominator, try to see if you can simplify it first, okay? All right, let's take a look at some more. Okay, so here we go. So now we're not dealing with just square roots, we have cube root here. So, well, if you need to in your calculator, you find cube root, or you could think about it this way. These are the same thing. This is 27 to the 1/3, a to the 4/3. Okay? And you could just do 27 to the 1/3 power in your calculator as well, but this is 3. And now, this is the part we need to talk about. So there's a couple different ways. You can think about a to the 4/3 as a to the 1 1/3, where a, see how you have a to a whole number and then the fraction left over? So that's like saying this, a to the first times a to the 1/3, which is this, a cube root a. So that's, so this is what the final answer would be for this. Or another way to think about the a to the 4/3 here is a to the 4/3. Well, that's the same thing as 3/3 times a to the 1/3, which is a times cube root a. Okay, but either way, we have to be able to simplify down to this. Let's take a look at some more. All right, so fifth root of 486. So I'm going to just plug that in the calculator, see if it is, because I have no idea off the top of my head. So it is not a perfect fifth root. So what I did was, this is what I did in my calculator. I did 486 divided by 2 to the fifth. It was a decimal. So then I did 486 divided by 3 to the fifth, and it told me it equaled 2. So then calculate what 3 to the fifth is. You get 243. So I can break this into the fifth root of 243 times the fifth root of 2 times x to the 7/5. So this would be 3 fifth root 2, and then over here we have, remember I said that'd be 1 and 2/5. So that'd be like x to the first times x to the 2/5. So I have 1x that comes out right here, and then 2, and then the x squared, because it's to the second, that stays under. Let's do a couple more. All right, 56 is not a perfect square, 8 is not a perfect square, but if I divide 56 by 8, I get 7x squared. So then I can break that into square root 7, square root x squared, which would be x square root 7. Okay? So again, regardless of the numerator, denominator was not a perfect square. So try to simplify so we don't end up with a denominator radical. Okay? Negative. Just remember there's a negative out there. Okay? And then I have y to the 5/3. Cube root of 27 is 3. Cube root of x to the third is x. Or let's do it this way, 3/3. Because now 3 divided by 3, that's just x to the first. So I have negative. And then I could say that's y squared times y, or sorry, jumped ahead, made a mistake. So that'd be 1 and 2/3 over 3x, which would be y to the first times y to the 2/3 over 3x. Almost forgot my negative. So my final answer would be negative y cube root y squared over 3x. Okay? Got a few more to go. Alright, so here's the problem. It says simplify completely. You're not allowed to have square roots in the denominator. So see how you have square root 3? See how we have the square root of 3 here? So what we need to do, multiply by square root of 3 over square root of 3. So you get 3 square root of 3a. See how these are both underneath the square root, so it's just 3a. And then this would be 3 times 3 is 9, but what's the square root of 9? 3. So I have over 3b. So the 3's cancel, and you get square root of 3a over b. Okay? So again, not allowed to have a square root in the denominator, so you go square root 2 over square root 2. So I have 8 square root 2 over 2, which is 4 square root 2. So hopefully we're seeing what we need to do here. Now cube roots, you can't have cube roots either, okay? Now this is where it gets a little tricky. So watch what I do here. Cube root 20x squared. Nothing I can simplify there because 20 can't get simplified at all. And x2 is lower than 3. So that's why I left it all in. Now the bottom here, watch what I do. I changed 9 to 3 squared, okay? And then watch. So you have cube root 20x squared over 3 to the 2/3 y to the 2/3. So now I have to think, how many thirds do I need to add to 2/3 to get it to equal a whole number? Well, 1/3 and 1/3. So I got to multiply the top and bottom here by 3 to the 1/3 y to the 1/3. And that's because, look, remember what you do when they have the same base, you add. What's 2/3 plus 1/3? It's 1. Okay? So that gets rid of our radical. So multiply that up here. You have 3 to the 1/3 times y to the 1/3. So then we have cube root of 60 x squared y. How did I get 60? Well, see how this has the 1/3? This means cube root, so it's underneath. So 3 times 20 is 60. And over 3y. Excuse me. Now what we have to do is we have to see still, can we simplify this square to 60 by any perfect cubes? So remember, do on your calculator 60 divided by 2 to the 3rd. That did not work. Okay? And then do 60 divided by 3 to the 3rd. Nothing. 60 divided by, well, 4 to the 3rd is, it's smaller than 1, so there's nothing I can simplify. So I am done. Okay? Let's take a look at some more. Alright, so it says, given the triangle, find the length of the missing side. So you have 6, 14, and c. So remember, a squared plus b squared equals c squared. So you have 6 squared plus 14 squared equals c squared. So 6 squared plus 14 squared. You have 232 equals c squared. Square root both sides. And it's not plus or minus because it's a length. And now what we need to do is we need to simplify the radical. So 232 divided by 4, okay, is 58. Why did I use 4? Because that's a perfect square. Can I divide that by 4 again? No. So you got to see, though, can you actually simplify it more? And I don't. No, you can't. So this is going to break down into square root of 4, square root of 58. So it would be 2 square root 58 inches. Important for tests, remember to label. Alright, so it says the time t in seconds for a pendulum of length L in feet to go through one complete cycle in its period is given by the formula t equals 2 pi square root of L divided by 32. Find the period of the pendulum whose length is 4 feet. Now this one we just get to round, so that's nice. So it says t equals 2 pi times the square root of 4 divided by 32. So you can enter all that in your calculator. Now, be careful. It might say to use in the homework 3.14 instead of the pi symbol. So that's what I'm going to do here. So 2 times 3.14 times the square root of 4 divided by 32. And it says the 2 decimals, so it's going to be approximately 2.22 feet. Okay? Let's take a look at a little more. Alright, so it says a ladder is leaned against a house in hopes of reaching a window. The window is 26 feet off the ground. The base of the ladder is placed 10 feet away from the house. Okay, so let's think about this. 26, 10, and they want to find the length of the ladder. Okay? So it says draw, we did that. Find the minimum length of the ladder needed. Well, it's a squared plus b squared equals c squared. So you go 26 plus, or 26 squared plus 10 squared 776 square root. Again, we're looking for length, so you don't have to do plus or minus. So you get x equals. Now, again, I would round here because I've never heard anyone say, like, yeah, it's 2 squared 2 feet long. Okay? So it says x is 27.85. So I would say x has to be approximately 28 feet because, again, there's not a ladder that's going to be 28 points or 27.85 feet. Okay? See you guys in class.